principle of superposition applies to electric fields. If we were to place a positive test charge near n point charges, they will each affect the test charge, and that net force on charge Q naught will be given by a principle of superposition. Like electric field at that point, at the position of the test charge, will also be the sum of all of those fields. So now if you were to take one charge and put another one and another one and another one, they all will affect that test charge sort of individually, and at the end you are going to add all of them together. So now here's a question. Here's a good example. What direction of E experienced by the point charge placed at P, the point P? So you have these charges that are already here, and you need to calculate what the E will be that is experienced by the charge at point P. Okay, so now let's do that question on the board. Okay, so here's our problem. We have 4 charges here. I'm going to call this 1, 2, 3, 4, just to make my life easier. But it's given that these charges are plus Q minus square root of 2Q plus Q, and I believe it's plus 2Q here, right? Okay, now what will happen? First of all, I need to find, what do I need? I need to find E at point 4, right, at charge 4. This is my job for today. Okay, now how do I do that? Well, first of all, I need to find what my E total will be due to all of these charges. Well, my E total, if I treat this as a test charge, it will be E1 plus E2 plus E3, right? That's what it's going to be. So I have to find the E total due to all of these charges. So first of all, I'm going to calculate which ones are positive, which ones are negative. Okay, charges. So let's talk about positive charges. This is positive, and this is positive. Okay, that one is negative. So my E field that this will experience due to E3 will actually be directed that way, right? Because E fields go outwards. This will be here, and that I'm going to call E1. And E2 will actually point that way because it's negative, right? We all understand that. So I'm going to draw my sphere to make my life easier. So what is E1? E1 is going to be KQ over A squared. So this is A, this is A. They're all equal. E2 will be KQ over R squared. If I call this R, okay? And E3 will be KQ over A squared. Do you all agree with that? If this is A, this is A, this is A, this is A, this is R, then those values will hold true. Now what is R? R is nothing other than A squared plus A squared square root. Yes? Which means R is 2A squared square root, or 2 square root 2A. Good? Okay. The rest of them remain the same, except I get KQ over square root 2A. Actually, I get 2A, right? That makes my life a little bit easier. Now, what is Q1? Q1 is just plus Q. Sorry, I should have probably wrote that. So this would be KQ over A squared. What is Q2? K minus, minus square root of 2Q divided by 2A squared. Okay? And what is Q3? KQ over A squared. Sorry, this should be Q3, right? These are the charges. Okay. Once I have all of those in, all I have to do is plug these numbers into here. So E1 will be a KQ over A squared plus KQ. Okay, I'm going to mess this up, but it'll be minus square root of 2Q over A squared plus KQ over A squared. I can take KQ over A squared common. I will be left with 1 minus 2 over 2 plus 1. Agree? So then I can simply KQ over A squared. I can simplify this to give me 2. 2 minus square root of 2 plus 2, right? And that gives me KQ over A squared, 4 minus square root of 2 divided by 2. And that is what my E field will be that this charge experiences due to all of the other 3 charges.